Hi everyone, this is Pierrick from P2design. In this mini course series, I will show you how to do this. This is a 4-part step-by-step tutorial series where you will learn how to create this real-time explosion FX in Blender using EEVEE. You can get all the Blender files for free exclusively on my Gumroad page. Just click I want this and set the price you want. If you want it for free, set a price of 0, or you can pay $1 million if you will. This is the same method I've used to create the FXs of my animation course teaser. We won't use any smoke simulation, only particles and simple planes and shaders. FXs can't be exported to a game engine like Unity or the Unreal Engine, but you can reproduce the same FX with the same method in engine. So this mini course is a good way for you to learn the basic of real-time FXs and also to improve your animation in Blender using this kind of FXs. Let's get started. We will start this tutorial by creating a background plane that will help us have a sense of depth for our explosion. I have my default Blender scene open. I will get rid of the cube and the point lamp. In object mode, let's add a plane, then scale it to make it bigger. I will then enter edit mode, select this edge and press E to extrude and then Z to extrude along the Z axis. Then select again the edge and press Ctrl B to bevel it. Using the mouse wheel, you can increase the number of cuts to get a smoother bevel. By left-clicking, you will confirm, but you can still edit your bevel by opening the contextual menu in the bottom left corner. Back in object mode, I will right-click on the object and choose Shade Smooth. Then I will get back into edit mode to make the object wider by scaling it, in my case, along the y-axis. Since we've scaled our object both in object mode and in edit mode, its scaling is not set to 1. That's not super important, but I always prefer to have my object with a scale value of 1. To apply the current scale as being the default scale, we can press Ctrl A and choose Scale. From there, I will rotate the object along the z-axis by -90 degrees so that it's aligned with the front view. I will then press Ctrl A again and choose Rotation and Scale. You can also choose all transforms. From there, we will position the camera so that it's aligned with the front view. We will then build our FX toward the camera. First, let's cancel the rotation of the camera by pressing Alt-R. As we do, the camera will be pointing down and all its rotation channel will be set to 0. Then I will set the X location to 0. And finally, I will press 3 on the numpad to get to the side view. And I will push the camera a bit backward and rotate it. From there, I will drag a new panel, make it a 3D view and press 0 so that we jump into camera view. When I'm in camera view, I don't like to see what's out of the camera view. With my camera object selected, I will go into the camera option and go to Viewport Display and set the Passepartout opacity to 1. Now everything out of our camera view has turned to black. By default, Blender is using EEVEE as the render engine, and this is the render engine that we are going to use for this tutorial. In my camera view, I will switch the shading to preview mode, and now our scene is rendered using a default HDRI that is shipped with Blender. You can now select the ground object, add a new material to it, and call it ground. From there, I will expand the timeline and switch to the shader editor or material editor. Before we go any further, you should have the Node Wrangler add-on enabled. So go to Edit, Preferences, Add-ons, and search for Wrangler. Then make sure it's enabled. This should be set by default in Blender since everybody uses it whenever it comes to shader editing. By default, our material is shipped with a principal BSDF. We can change its color, we can increase the roughness, or at least reduce the specularity to 0.1. Regarding its surface color, I prefer to add a texture, checker texture. And then I will plug the color output of the checker texture into the base color input of our principal VSDF. Now we can see this checker pattern onto our surface. I will increase the scale so that we have smaller checker pattern, and then I will use darker tones so that we don't have this bright white background, but something darker. Having a dark background will emphasize the brightness of our explosion and make it easier to read. Just use 2 different dark grays and it's gonna be okay. You should see that our pattern is not really even. That's not a big deal, but we can easily fix it by going into edit mode, press A to select all the vertices of our object, U to open the unwrap menu, and choose Unwrap. This will create a new UV map for our object, and now we can use it by selecting the checker texture, pressing Ctrl T to create a texture setup. We can get rid of the mapping node and plug in the UV coordinates inside the vector input of the checker. Now we have a cleaner checker pattern onto our ground, even if it's not perfect. That's gonna be enough to go ahead and start working on our explosion. Whenever you are working on an art piece like a VFX, it's always better to start with the big shapes before adding details. So we will start building our FX, focusing first on the flame and smoke particle. Before that, I will name the first collection including the camera and the background set, and I will create another collection that I will call Explosion. Our main particle is going to be a simple plane, so I will press Shift A and add a plane. I will go into edit mode and rotate it on the x-axis by 90 degrees so that it's facing the camera. Then I will go back into object mode and I will move it a bit up so that it's fully framed. We can then rename it through the outliner or pressing F2 to open the rename panel. So I've called this plane Explosion Particle. We will add to it a new material that I will call Explosion. By default, a material is set to opaque. While we don't care when using cycles, when using EEVEE, if my material is set to opaque and I play with the alpha, its transparency won't change. It will just turn to black whenever I set the alpha to 0. To be able to play with transparency, we need to set the blend mode to whether alpha clip, alpha hashed, or alpha blend. Let's try alpha blend. When using alpha blend, as soon as I change the opacity, we can see our plane fading. If I now switch to alpha hashed, our plane will dissolve. Random pixel on the surface of our plane switch from fully opaque to fully transparent. This is a cheap way to simulate transparency. Finally, the alpha clip mode allows you to get whether fully transparent or fully opaque. This is ideal to create holes into a fabric or to create stylized FXs. For this tutorial, we will stick to alpha blend. We don't need our particles to cast shadow, so you can set the shadow mode to none. By default, our plane is unwrapped, meaning that it has UV coordinates. Whenever I enter edit mode and I open the UV editor, we can see that it's already unwrapped following the bounds of the UV map. The UV map is a simple plane with coordinates on X and Y that goes from 0 to 1. And this map is then projected onto the 3D object. In our case, it's a simple plane, so it's very easy to interpret those UVs. The first thing we need to do is to bring transparency toward the edges of our plane, so that we don't see the current geometry. With the principal BSDF selected, press Ctrl T to bring in a mapping setup. Since we are going to use procedural texture, we can get rid of the image texture. From there, we will change the mapping type from point to texture. It just changes the way coordinates works and makes it more artist-friendly. Then we press Shift A to add a new node, go to Texture and choose Gradient Texture. We can plug in our coordinates and then plug the color into the color of the principal BSDF. By default, the gradient is set to linear and it will create a gradient that goes from black to white along the x-axis of our UVs. We want a round gradient, so I will choose quadratic sphere. We now have a spherical gradient centered on the origin of the UVs or the point 0. To move the center of the gradient, we just need to change the location on X and Y from 0 to 0.5. To contrast our gradient, let's add a converter color ramp. You can then drag and drop it between the gradient and the principal BSDF and play with the flags to contrast it. We can then use the color ramp to drive the alpha of our material. Then you can unplug it from the base color so that it's only driving the alpha of the material. Let's now give some shape to our cloud. We will add a first texture node, noise, and we will plug in the mapping node so that it uses the same coordinates as the gradient texture. Then, to combine them, we will use a color mix RGB. I will plug the factor of my noise texture into the color 2 socket and the gradient into the color 1 socket. I will then use this mix RGB as the alpha of our principal BSDF. I will change its blending mode from mix to multiply, and then I will push the factor to 1. I can now Ctrl-Shift left click this node to preview it thanks to the Node Wrangler add-on. Let's now turn this texture into a cloud of fire. I will first add a converter map range, and I will explain you why a little later. Then let's add a converter color ramp. I will drop it after the output of the map range and I will Ctrl left shift click it to see the result. Nothing has changed. So let's give it some color. Select the white flag of the color ramp and set it to a bright yellow. Then let's add another control point or flag and set its color to a bright orange. I will add a bright red and a bright yellow. Finally, I will slightly push the black so that we can see the edges of our plane. One of the most important things to understand whenever you are working on this kind of effect or on a shader is that we are manipulating values, not colors. Eventually those values will become color, but you have to understand that everything is about mathematical values. On our current texture, the black part is almost 0, and the brightest pixel have a value of almost 1. Values that are 0 or below on our color ramp will be black, and values that are 1 or beyond will turn to this bright yellow. So we can see that the texture we have created follow these rules, and we get this colored texture. The map range node allows us to change the minimum and maximum value range. And it can also convert it. So it can take a gradient that goes from 0 to 1, for example, and say any pixel from 0 to 1 will become 0 to 10. It's like multiplying them by 10, if you will. When we Ctrl-Shift left-click one of our nodes, it creates a viewer node that is a simple emission shader. So let's use our color ramp to drive the emission instead of the alpha. This way, our plane will emit light as an explosion would do. I will now Ctrl-Shift left-click the principal BSDF to see what it looks like. And it's all white because its base color is white. Let's switch it to black. Now, if I play with the from maximum value of the map range node, more and more pixels will be above the current value, and so our plane will become brighter. Let's increase the strength of our emission by inputting an emission strength of 10. Now, to get a better sense and a better effect, let's enable the bloom in the render option of EEVEE. Now, if I increase the from maximum value, it will become darker and darker. So we will be able to animate this value to create our blast effect or flame effect. We have built the very basic of our flame. We now need extra control. To be able to control the opacity, we will add a new map range node. We will use the previous map range node as an input, and we will plug the output into the alpha of our principal BSDF. This will allow us to fine tweak the transparency of our fire cloud during the animation. I have also tested with a color ramp. It can work, but you have less fine control over the transparency. So eventually I will switch back to the map range node. I want to be able to control my noise and control our gradient texture. I will add a simple color ramp to control the noise as we just need to contrast it. It is multiplied upon the gradient texture. If we add more black, we will dig holes into our texture. And if we crank up the white value, we will have more intensity into our flames. To make our pattern a little more interesting and realistic, I advise you to increase the detail level. A value of 5 should be fine. It basically adds extra noise upon your current noise texture. Finally, I want to be able to fine tweak the values of the gradient texture. So I will simply duplicate the map range and put it just after the gradient texture. Playing with the 2 minimum range, I will be able to shrink the explosion size. Increasing the from maximum range, we will be able to make the shape rounder and increase its base value, making it brighter. This will be perfect for the beginning of the explosion. I will try to find the from minimum value that avoid this explosion shape to clip with the edges of the plane, and the value of 0.25 seems to be perfect. So basically we are going to play with the from minimum and from maximum values for our explosion on this map range node, but you can experiment with the other value and see what's happening. Playing with the 2 maximum value will allow us to increase the brightness of the explosion. So this is another value that we could be editing later on. As explained before, I will use a map range node to drive the alpha or the transparency of our effect. It should already be the case at your side if you've been following the tutorial. Reducing the from maximum value, I will increase the opacity of the overall effect. And a value of 0.05 seems to be perfect. Now, any pixel that has a gray value over 0.05 will be opaque. Whenever you are playing with the map range, don't forget that sometimes you have to be very subtle with the values, and sometimes you can go very broad. Up and now, when I play with the from maximum value of the gradient texture, I get a nice evolution from flame to smoke. I'm now tweaking the from minimum value of the map range node that drive the color of the flames, and the idea is to get rid of the remaining flame effect onto the shader. So a value of 0.08 seems to be perfect. Now that our cloud is able to evolve from flame to smoke, I like those flame or smoke to move a bit. The cool thing about procedural textures is that you can make them evolve. If we head over our noise texture, we can switch from 3D to 4D. And now a new attribute has appeared called W. If we play with its value, we can see our noise texture shape changing. And it does it in a very organic way. I will now create a new tab by dragging the bottom left corner and change it to the timeline. I've set the end frame to 100. Now, instead of animating this value by hand, I will type in hashtag and frame. This will automatically create a driver that will input the value of the current frame. On frame 1 it will be 1, on frame 10 it's gonna be 10. So it makes our shape evolve a bit too fast. I will right click on the driver and get rid of it. And this time I will type in again hashtag frame multiplied by 0.01. If I now press the spacebar to play the animation, we can see our shape evolving in a more subtle manner. Another little issue I'd like to address is that we are going to use this plane as a particle. So it's going to move and be duplicated. To be able to see its outline, I will re-enable the overlays. Then I will duplicate the plane a couple of times. If I select those three planes and I move them, we can see that they are identical and they don't change. And when you want to build a convincing FX, you don't want to see the repetition or the pattern into the FX. To break this, we are going to change the coordinates of our noise texture. The first thing we need to do in the 3D view is to add an empty object. Then I will select back one of the plane, and instead of using the UVs, we are going to use the object coordinate. So I will duplicate the texture coordinate node, and I will plug in the object into the vector of the noise texture. In the texture coordinate node, in the object input, I will select the empty. Now we can see that our noise texture is smaller, so I will reduce the scale to 3 to get something closer to what we had before. Now when I move the empty, we can see the noise moving onto the surface of our planes. And if I now move the planes, it seems that there is a background texture that slides upon them. Now I'd like to go a little further to get a very convincing effect. If we have a look to the different coordinates of our mapping node, we can see that the output is basically a color. So we can create distortion by slightly modifying the color of those coordinates. To do so, I can duplicate the noise texture node and plug in the object coordinates. If we Ctrl-Shift left click the noise texture node a couple of times, we will be able to see its color. And we can see that it's a variation of red, blue and green. So if I now mix this color with the coordinates of our texture, it's gonna input a bit of distortion. So I will simply add a mix color RGB node, and we will input it between the mapping node and the vector input of our textures. And in the second color socket, we are going to use the color of our noise texture. I will set the factor to a very small value like 0.1 and Ctrl-Shift click the first one to show you what happened. We can see that now our coordinates are slightly distorted compared to the version without the mix RGB node. So if I now play with the W value of this node, it will make the noise texture evolve and we can see the distortion appearing upon our planes, as if there was some heat wave upon the current texture. Make sure you reduce the scale of the noise so that you get broad distortions. And in the W value, you can type in hashtag frame multiplied by 0.05 and press the spacebar to see the result. This is the end of this first tutorial. In the next one, we are going to create the particle system to use those flame planes. Don't forget to click the like button if you did, and I will see you in the next video.